Well, hi, Benjamin. I thought what I would do is go over a couple of these problems from your Punnett square lesson to see if it helps. So for now, I thought I would try 1 and 5A, B, and C. So number 1 here says, and this will be on your video. When you open up that lesson for the Punnett squares, you pull up my video and then you go through it and then you stop, and then if you want to see the next problem, you turn the video back on and you go until the next problem comes up and you stop. I just did it a little bit different. But this one says, number 1 says, let's make our Punnett square here first. If a green pea plant, capital G, little g, so evidently we're going to cross a capital G, little g. So this plant has a dominant allele as well as a recessive allele. We're going to cross that with a yellow pea plant. Now, when we're talking about the colors of the plants, green is dominant, yellow is recessive. Anytime a plant has at least one capital letter or dominant allele, that plant is going to look green. So the only way that we could get a yellow one is if both of the alleles are the recessive form. So we know we're crossing with that. Okay. We're going to put one of the plant's alleles up here, and we're going to put one of the other plant's alleles over here. And it doesn't matter which one you choose to go with which place. The answers come out the same. So we'll take this one, G, capital G, little g, and I'll put it at the top here. Notice that I kind of put it in different columns here. And for this plant, who has the 2 recessive alleles, I'll put them over here. So it's almost like this is the dad maybe over here, and this is the mom up here. Then you can tell what you're going to get as far as the babies by looking at, you take this one here and you drop down and you see where it meets this one here. So that baby could be a capital G, little g. That's one possibility. If this mom in her egg gave a capital G and the dad in the sperm gave a little g, that baby would be capital G, little g. So this one here, what if this one was put into the egg, the lowercase g, or the recessive form of the allele for the egg, and the sperm, dad had the lowercase g or recessive form also. That baby would be GG. Same thing with this one. What if mom put this allele, this chromosome, or this allele in the egg, and dad put this one? This baby could be, which is just the same as the other one, capital G, little g. And same with this one, drop down over here. This baby could be little g, little g. So those are the only babies that this particular mom and dad could have are capital G, lowercase g, and a lowercase g, lowercase g. Those are the only type of babies that this particular mom and this particular dad plant could have. Now, when they talk about genotype ratio, it has something to do with the genotype. And do you know what the genotype is? The genotype is the letters, the actual alleles that are represented in an organism. Like for the color here, this baby here is capital G, lowercase g. That's the genotype. This baby here has a genotype of lowercase g, lowercase g. That's the genotype. So when we talk about the genotype ratio for the Punnett square that we just did, we go through the process. All you're going to do is count. You look and see if there's any capital G, and then you look to see if there's any capital G, lowercase g. And then last, you look to see if there's any lowercase g, lowercase g. You just put it down in a ratio. So there's no capital there. I don't see any, so that's a 0. So just leave that off. How many capital G, lowercase g's do we see out of the 4? I see 1, 2. Then, last but not least, how many lowercase g's do you see here? You see 2. So the genotype ratio is 2 to 2. That means that there are 2 capital G, little g's out of the 4 for every 2 lowercase g, 2 to 2. Now, if you talk about the phenotype ratio has to do with the phenotype And the phenotype is what it looks like to your eye. If I look at it, like say I take this baby right here, I can see that the genotype is capital G, lowercase g. But what color is that baby plant if I look at it? Is it green or is it yellow? Well, because it has at least one dominant allele here for the green color, that baby would look green to my eye. So there's only two colors that the plants could be, green or yellow. So you count the dominant trait, the green, first. And out of the four, there are two, this one and this one, that have a dominant allele. So those would be green if I look at them. So I'll put two of those. How many of the four will look yellow when I look at them with my eye? Two. So in this particular case, the genotype ratio and the phenotype ratio aren't the same. They won't always be, but in this case they are. Okay. So let's go on to another one. Let's go on to, I may let you try 5B and C by yourself. Let's try number 5A. Remember, we're going to skip 3 and 4. So no 3 and 4. Okay. 5A says, what are the genotype and phenotype ratios? So they're asking for ratios again. And A says cross 2 heterozygous long-winged flies. Well, first of all, you have to know what heterozygous means, right? Okay. Heterozygous means that the alleles here, when you have an organism and you look at the alleles for a particular trait, means that they're different. So this would not fit that. This would. I see a dominant and a lowercase here. That's heterozygous. Would this one be? Yes, because there's a dominant and a recessive allele. They're not the same. This would be an example of heterozygous. This and this would not be. What we call them, where they're the same like this, it could be either this or it could be this. We don't call them heterozygous. We call them homozygous. If they are the same, we call them homozygous. If the alleles are different, we call them heterozygous. This one here would be homozygous dominant because there's two dominant alleles. This would be homozygous recessive because the two of them, they're the same, but they're just recessive alleles, okay? So down here it says cross 2 heterozygous. So right off the bat, if I know what heterozygous means here, I know that both mom and dad are going to look more like this, aren't they? So I'm going to cross a, let's see, are they talking about the wing? It doesn't mean, I won't use G this time. You can use whatever letters you want, but just know that whatever letters you use, you have to use the dominant, the capital and the lowercase. You don't switch letters for dominant and recessive. You use the same letter, but one will be a capital and one will be a lowercase. I'm going to use L, just for fun. So I'm going to let L be the dominant, and that's for long. I do know that long is the dominant form. And so lowercase l will be the recessive, and the recessive shows up as being short wing, kind of a shriveled up little wing. And you'll notice I use the same letters here, capital L and lowercase l. Okay, so let's see. I have to cross 2 heterozygous long-winged flies. So the big long wing, they have to have at least one capital L, don't they? But because I know they're heterozygous, I know that we're not going to have both of them being capital letters. It has to be this. That way, this particular mom shows up with long wings, but she is heterozygous. She has a dominant and then a recessive gene. It's just that when I look at it, I do see her being long-winged. And if we want to, the dad has to be the same thing, they said. So there's our 2 heterozygous long-winged flies. Okay, so let's see what we get. If this egg came together with this sperm from this baby here, this baby would end up being capital L, capital L. If this egg came together with this sperm, that baby would end up being capital L, little l. And did you notice that I always put the capital first? If you find that you have a heterozygous state where you have a capital letter and a lowercase, the capital letter always goes first. How about this one? If this egg came together with this sperm, oh, there's another capital L, lowercase l. And how about if this one was put into the egg and this one in the sperm? That baby would be lowercase l, lowercase l. So a little bit different here, which is nice to have a different example here. Let's do the genotype ratio. And the phenotype ratio. Okay, so the genotype ratio means we're looking at what the actual alleles are. Do you see any dominant of the babies? Yeah, I see one. Do you see any capital letter, lowercase letter? Yeah, I see two of them here. And do you see any lowercase of the four here? Yes, I do. I see one of them right there. So the genotype ratio is 1 to 2 to 1. The phenotype ratio is going to be a little different here. The only thing that the flies can be when I look at them, because that's what the phenotype is, what do they look like when I look at them with my eye? They have to either be long-winged or they can be short-winged. So of the four, I have one long-winged. I have another one here because it has at least one capital letter. I have another one here. So I have 3 long-winged to how many short-winged or shrivel-up-winged? Only 1. So that is the phenotype ratio. Okay. So you'll notice to do these problems, you have to not only be able to just do the problem, you have to know what the word genotype means. You have to know what the term phenotype means. And then you have to know what the genotype ratio and phenotype ratio mean, as well as a couple other little terms. Heterozygous, and I didn't write this here, but homozygous. So heterozygous are when the alleles are different, like this parent was and this parent was. Homozygous is when the two alleles are the same. They're either both capital letters or both dominant, or they're both lowercase letters, so they're both recessive. Okay. All right, so I'm going to send this to you, and I hope that helps you get started on your Punnett squares. Okay, bye. See if I can turn this off now. Might take me a second. Let's see. Here we go.